Okay, so I want to talk about Bayesian population projections with migration uncertainty. And this is my website. This is the website of our research group. And this particular work is joint work with John Azos, who was a PhD student of mine at the University of Washington. Sorry, my voice is suffering from a sleepless night in Boston Airport.
You want to use the mic?
What?
Would you like to use the mic?
I think I'll. Let's see how it goes. I think we'll see. But the he's now at Google, and Hanna Shevchikova, who's a senior research scientist at the University of Washington, and this is partly the fruit of a quite long-standing collaboration with the United Nations Population Division, and I want to acknowledge the research support. Since 2006, so 12 years of sustained research support by the Eunice Kennedy Shriver National Institute of Child Health and Human Development, or NICHD. So this topic, I think, is very important, not just technically and statistically, but also in terms of public conversation, particularly over recent years in the West. And just as an example where actually population projections and the role of migration has been very important in public policy debate. Some of you may remember that 2 years ago the United Kingdom held a referendum on whether or not to leave the European Union, the so-called Brexit referendum. And one of the main campaigners for Brexit, for leaving the EU, was Boris Johnson, a senior Conservative politician who is now the Foreign Secretary of the United Kingdom, equivalent of Secretary of State. And he, a main theme of his campaign, which resonated pretty deeply, was that essentially the UK, if the UK stayed in the EU, it would be kind of swamped by migrants from other EU countries using government services and so on. And he crystallized this by saying the UK population will hit 80 million if we stay in the EU, from 65 million now. So, and the kind of question which one would like to know is, how likely is this actually to happen? And actually the most current standard methods for population projections don't actually provide an answer to this question, which I will, and the methods that we have developed do. The Brexit referendum passed by a very slim margin. It was passed by 4 points, and it's thought that this contention, played a big had a big impact on the votes, and possibly may have even, flipped the results. So with obviously very far-reaching implications for the UK and Europe and kind of world affairs generally. So this is an important issue, and of course we know in the United States it's also the subject of a lot of discussion and debate. So this work is taking place in the context of population projections or forecasts, and these are used by governments at all levels, whether city, county, state, national, and indeed international organizations, for planning purposes. So for planning government services of whether it's education or health or infrastructure, then the population projections or forecasts are basically key input to pretty much all government decisions. Also by the private sector for strategic planning, and by researchers, particularly in the health and social sciences. And I think it has been argued that population projections are, possibly the biggest single contribution of the social sciences to society at large, which is, of course, there are others like opinion polls, for example, but that have also had a big impact. But this is the impact is huge. Now, the main organization that regularly publishes population projections for all countries that are updated, regularly in light of the most recent data on the past, is the United Nations. And the UN publishes projections of population counts by age and sex, and also vital rates, by which I mean fertility rates or birth rates, mortality rates or death rates, and also migration rates, international migration rates for all countries. They do this by 5-year age groups in 5-year periods, and they project forward from now to 2100. They also estimate the past from 1950 to the present. And these estimates of the past are the basis for the projections into the future. And these are updated every 2 years and issued in a series of publications called World Population Prospects, which used to be kind of volumes that you'd find in big volumes you'd find in the library. And now, of course, it's a website that's regularly updated. So how are these produced? Well, the traditional method that has been standard since the 1940s, it was really became kind of ensconced. It was invented by a British statistician and biologist called Edward Cannon in the 1890s, but it was really established as the way to do population projections by an American statistician called Pascal Whelpton, who was in the 1930s, who was the director of the US Census Bureau, and published an article in the JAMA that is the basis for this. And basically, it starts, a very simple method, but also sophisticated. It starts from current population estimates and projects population forward by age and sex deterministically, using an age-structured extension of the so-called demographic balancing equation, which looks like this. So it says population at the next time point is equal to the current population, plus the number of births in the intervening period, minus the number of deaths, plus the number of immigrants, minus the number of emigrants. And the one great advantage of this equation is that it's actually true, which is which is not necessarily always the case of every equation you might see in a seminar. So and this, if you've got birth and death and migration rates, this provides a very simple algorithm for projecting forward. It's just basically nothing more than arithmetic, a bunch of very simple arithmetic additions and subtractions. But of course, there's no free lunch, and it requires assumptions. To do that, it requires assumptions about future fertility rates, mortality rates, and migration rates. So in the standard approach, where do these come from? Well, they come from experts. So they are typically produced by in-house experts. In the case of the US Census Bureau, for example, there's a small population projections unit, and they think, for example, what will be future fertility rates in the United States. So the total fertility rate is a measure of the number of children a woman would have, given current age-specific fertility rates. And who knows what the total fertility rate of the United States is right now in children per woman? Or who can?
1.8.
1.8. That's really close. It's 1.85. Yeah, that's. I think that's. Put that man on the Supreme Court. Yeah, that's about the closest I've done this at. Given this talk a number of places, including Harvard and Duke this week, and nobody got that close actually. Okay, so so it's 1.85 now, and maybe they say, okay, I think in 2060, which is what the US projects forward to, it'll be 1.7, right? And they kind of think about that and come up with that out of they intuit that. Similarly, well, so the US Census Bureau does that. The United Nations used to do that before they started transitioning their methods to the methods I'm going to be talking about that we've developed along with them. The German federal statistical system, instead of having in-house experts, they convene a panel of kind of leading German demographers, statisticians, economists, and so on, and the panel sort of collectively does the same as the in-house expert in the United States. So, what's good and what's bad about experts? Of course, we're all experts here, right? So fortunately, there's something good about experts, and experts are very important for this process. Experts are good at identifying what's the correct underlying science, what are the right data to make projections like this, what's the assessing data quality, and also building models and assessing the output of models. Does it make sense, and so on. So experts are good at all of these things. However, unfortunately, they're not good at producing forecasts from scratch, and there's a long literature that goes back to the 1950s that shows that, if you just ask experts, for example, what will the total fertility rate in the United States be in 2060, they're not good at that, even though they might be good at assembling a scientific approach to answering that question. And it's kind of interesting, this history. The 1950, there was Paul Meehl. Has anybody heard of Paul Meehl? No, he's a psychologist, and he wrote a little book called Statistical versus Clinical Prediction. And he considered quite a few prediction, medical prognoses, other kind of predictions in kind of clinical practice, I think maybe including social work kind of practices. But he then compared very, very simple, naive statistical rules of thumb from that era with the considered opinions based on lengthy experience of very well respected and experienced eminent doctors, specialists and so on, with a lot of training and experience. And he found that the very simple, naive statistical rules of thumb substantially outperformed the eminent and highly respected doctors. And of course, this was a very scandalous result at the time, because the doctors, like most experts, they felt, I have my experience, I know what's going to happen, and it turned out they didn't know. And so it led to about 30 years of studies to refute Meehl's conclusion, and the outcome of the 30 years of studies was to confirm what he had found. And there have been similar findings in demography, also in political science. There's so Philip Tetlock, who's heard of Philip Tetlock? So okay, a few people have. So basically, 2005 he wrote a book called Expert Political Judgment, which he basically looked at about 30,000 political predictions, like, will President Assad still be president of Syria at the end of next year, that kind of thing. And he assembled maybe several hundred, maybe 300, again, well-respected experts, like professors of political science, who like your eminent selves, and but also TV pundits, State Department officials, politicians themselves, and so on. And he found that basically, as he put it, most experts perform no better than a dart-throwing chimpanzee. So this is so the experts kind of to kind of summarize the conclusion of this 60 years of literature, when it comes to making forecasts, ex ante, the experts suck. So, but still they're used. That hasn't been integrated. The medical profession has integrated this. So now, if a doctor gives you a prognosis, it won't be based just on his gut feeling and experience. It'll be based on the medical literature, large amounts of data which have been analysed, often using sophisticated statistical methods. But in demography, that's not the case. So we're trying to get beyond that, and actually this project started when the UN contacted me and said, we'd like to do better than we're doing right now. The other thing is assessing uncertainty. So we're all used to, here in this room, we're all used to estimates, predictions, whatever, being associated with a statement of uncertainty. So we all know it's very standard throughout science and indeed policy making to have standard errors, confidence intervals, things like that, the things that we learn about in the first statistics course. But here for population projections, this has not usually been done, and instead uncertainty is communicated by scenarios. So, for example, the United Nations they used to do high, medium, and low scenarios, which they still do as a kind of a legacy thing. And that, you might say, the high scenario said, we'll take our best guess at the fertility rate and add half a child. So we said, the total fertility rate in the United States is now 1.85, and you add half a child, it's 2.35. That's not outlandish to think it could be 2.35 in the future. But that's not what the scenario is saying. The scenario is saying that in every time point in the future and in every country, it will be half a child higher. And once you think probabilistically, that's an intersection. There are about 200 countries, 18 periods into the future. It's an intersection of over 3,000 events, each of which is on its own not outlandish, but not that likely. So clearly that's a low probability event. So and academic demographers and others since the 1970s have been making this point and saying, it's not a good approach. It's implausible over multiple time periods. There's no probabilistic interpretation, and it's you should do better. But the field and the agencies haven't really integrated this until now. So or implemented it indeed. So our approach is to develop probabilistic population projections. How do we do that? Well, there are three components of population change: fertility, mortality, and migration. Right. So the idea is to project each of these, and then combine them. So for total fertility rate, we develop probabilistic projections of the total fertility rate from a Bayesian hierarchical model, and this gives a sample of trajectories from the joint predictive distribution of the future fertility rate for each country and period in the future. And each trajectory is converted into age-specific fertility rates. A similar approach is taken on the mortality side for projecting life expectancy, and all projected life expectancy values are translated into age-specific mortality rates. And then the projection model, or if you like, the demographic balancing equation, which is sometimes also called the core component method of projection, is applied to each trajectory of fertility and mortality. And this yields many possible population futures of the world. So if you think, world population prospects 2100, it yields, many possible forms that would take, which represent a sample from the predictive distribution. So after a long process, starting in 2006, that involved methodological development, implementation, and trying it out, issuing parallel experimental products, and also expert group meetings where large numbers of experts were assembled to sort of beat up on the method. And in 2015, the UN officially adopted this as the basis for their official population projections for all the countries of the world. So, and again in the 2017 revision, the method was used again. And for the next one, which is currently in process, the 2019 revision, it's been done as well. So how about migration, which is kind of a stepchild of population projections? So projecting international migration is very challenging for a number of reasons. One is that the past data is not good. I say here the past data is not good in many countries. Actually, it's really bad in almost all countries. So the reason is it's very hard to measure, migration directly. International migration is defined by the UN. You're a migrant if you live in another country for at least a year. Okay, so if you think one of the preferred methods for trying to measure it is passenger surveys. Passenger surveys, lots of people go go out of the country, come into the country, and the permanent migration is very small. So you've got the inflow, the outflow, both are measured with error, and then the actual permanent one is maybe the difference of those, but it's probably a lot smaller than the error in the passenger survey. So that's one method. A lot of methods are that kind and really give essentially worthless results. So the United Nations, instead of trying to project migration between individual countries, it projects net international migration, which is immigration minus emigration, just total for a country. And there is a sort of a basis for that, which is not passenger surveys, but it's the so-called residual method using censuses. So if you take, for example, the 2000 census and the 2010 census, right, what you can do in 2000, basically there's a census, gives the population by age and sex. I mean, this is a very rough description, but then there's information about the number of births, the number of deaths in the following 10 years, and you can project forward to 2010 and say, okay, if there was no migration in the intervening period, here's what the population would look like in 2010. Then there's the census, where we get another set of numbers, and the difference can be attributed to migration, to net migration. The other reason is that net migration is actually all you need to be able to do population projections for an individual country. So this is a good, I think this is a very good choice for the purpose of population projections. projections. But what the UN does is it mostly assumes net migration counts are constant in each country to 2050 and then moves slowly towards zero. So it basically assumes the future is going to be exactly the same as the present. And if there's one thing we know about migration is that that's not true, right? So although it has a kind of advantage that it's sort of safe, I think people are prepared to say, okay, the future is going to be exactly like the present, even though it's not the case. And it's so that's one reason for why they've been sort of conservative in this way. But another way is they've no real basis for doing anything else. And these are adjusted. So a second big issue with migration is that you can't immigrate to the planet and you can't emigrate from the planet, right? So migration, that means migration across all countries has to sum to zero. So these are adjusted so that migration sums to zero across the world. And this is still deterministic. So now they're doing probabilistic, statistically based projections of fertility and mortality, but not migration. So that's what this part of the story it's kind of is about, and we've been developing methods for doing that.
Can I ask a question?
Sure.
I was just curious, why does everyone assume that net migration is going to move from zero eventually?
Why do they assume that? Well, it's a really kind of interesting clash of cultures. They kind of say, well, we really, when we go further into the future, we know nothing. So we'll assume it's equal to zero. And I've had this argument where I've said, well, assuming it's zero is a really strong assumption, and since you don't know anything about it, like that means you should have more, the intervals, it should have more uncertainty rather than less, but you're assuming, you're making a very strong assumption, which is exactly the wrong way to go. But the demography is, it's a discipline that relies on mathematical deterministic models. It's quite sophisticated mathematically. And these ideas of so they think that way, and there are other disciplines like climate science, a lot of areas of geophysics, meteorology, and so on, scientifically sophisticated areas that are based largely on deterministic models. And so they haven't really been thinking along those lines. So the idea that when you don't know anything about it, actually making an assumption at zero does not capture that was kind of a new idea in the field. So. But I think that's one reason is, that's the kind of technical reason that they would give or did give. But also I think that, somehow there's also, since it's such, the United Nations, of course, is a political organization, and that's, maybe they feel they're less likely to get pushback with an assumption of zero than with something else. I don't know. And the other reason, of course, is it's always been done that way. So, which is one of the most common reasons for doing things, actually, to find. Yes.
And the underlying supposition is that the census counts are an accurate reflection of true population, and there's no differences in countries in the degrees to which census counts might deviate from true population.
Yep.
Okay.
Yeah. And that's not a good assumption, but it's better than the alternative, right? Of relying on, say, passenger surveys or something. There's a few countries for which that's not true. Countries with population registers. So in Germany, for example, if you move to Germany, you have to go to the city hall and sign in, the same as if you rent an apartment, you have to sign in the same as if you checked into a hotel. And there's Poland, Italy. A few European countries have population registers, but not really not many. I think maybe 10 countries. It doesn't include the United States, of course. So some standardized facts to be taken into account in developing a model for net international migration. As I've said, it sums to zero across the globe in each period, but not only in total, but for each sex and each age group it has to sum to zero. Right? So that's a lot of constraints. A second thing is we have a kind of intuition about migration, because we live in the moment, that there are receiving countries like the United States, right, a country of immigration, and there are sending countries like Nicaragua, for example, or Guatemala, and that's our mental image. However, it's a misleading one, because countries often cross over between being sending and receiving countries, and indeed, if we look at the situation in 1950 and the situation in 2010, we find that of the countries that were sending countries in 1950, and that 46% of all countries were either sending countries in 1950 and receiving countries in 2010, or vice versa. And that means that essentially whether a country was a sending or a receiving country in 1950 tells you very little about what's the case now. And just to illustrate that, so if you go back to say 1950, there were 2 countries in the world that were, had say since in the period 1870 to 1950, there were 2 countries that had the most immigrants and had the biggest stocks of foreign-born country, and were thought of as the 2 biggest lands of opportunity in the world that people migrated to. What were they?
Australia?
No, not Australia.
United States.
So United States was one, then as now. So what's the other one?
Argentina.
Yes, very good. Okay, so that is usually it takes like 6 or 7 guesses because people guess Canada, Germany, France, UK, and the actually Brazil, but it wasn't any of those, and it is Argentina. And then very quickly by the 1970s, Argentina had gone through was a military dictatorship. It had gone through a period of severe economic mismanagement. Its economy had tanked, and it had become a country of emigration. So that shows that even a country that's really thought of as one of the prime lands of opportunity can actually very quickly change over to a country of emigration, and so the changes can be massive and can happen very quickly. And the fact that most people don't even remember, and certainly don't think of Argentina as land of opportunity. Yeah.
So I want to ask you a question about what a word you just used, which is very quickly, right? So my question is, so when we look at your first bullet point,
Yeah.
right, we're going to sum to 0 for each period, and then we're talking about about shifts over a 60-year period of time.
Yeah.
So when we talk about each period summing to 0, what's the duration of time that we're looking at?
Oh, these are
What's the
5-year
time
periods.
slice?
So this is all we're doing for the UN. So
So it's 5-year periods, but then
And-
but it is not, I mean, isn't it troubling that this movement in terms of, being a sending country and a receiving country, yes, that will equalize out potentially, but that may take 50 to 60 years.
No. This is just a completely technical thing. If you look at the number of migrants in a 5-year period, and you take 50 to 55-year-old women, you take and you find out what were the what was the net migration in each country, that has to add up exactly to 0, and that's all. It's not. So there's that's just a fact. So and that has to be taken into, since it's a fact, it has to be taken into account, or should be, in projections. So okay. So and it's kind of summarised the. Demographer Jakub Biak at the University of Southampton has kind of summarised that by saying international migration is barely predictable. So it's kind of can be, it's very hard to predict, but there's some predictability in it. So another kind of result is that this migration paradox, which we see in these plots here. And so basically, the first one here is that if we look at this plot here, on the x-axis we've got time from 1950 to 2010 here. And what we see on the y-axis is the proportion, and a kind of estimate of the proportion of the world population migrating. It's really a proxy for it, because we take, for each country, we take net migration, take its absolute value, and add these up and divide by world population. So it's a kind of a proxy for the proportion of the world's population migrating. Which would be if all countries were either purely sending or purely receiving countries, which obviously is at best approximately true. But we see that there was a steady increase, and in fact, by this measure, the proportion of the world population migrating more or less doubled over that period. However, if we do it another way, and we take for each country, we take the migration rate, again, dividing the number of migrants by population, and these are in people per 1,000, migrants per year per 1,000 population of the receiving country. And we average these across countries, not weighting by population. This is what we find, and we find basically, these are these squares lines, so we find there's basically no trend, which hasn't changed at all. So we find if we measure the proportion of the world's population migrating, it's been increasing, but the average migration rate across countries has been constant. And this seems somewhat paradoxical. And so one can think of various possible explanations. One is that all countries' absolute migration rates haven't changed that much, but the population of countries with higher migration rates has grown more. So for example, if the United States had high migration rates, that would be, the migration rate in the US increasing over time. A second possible explanation is that there have been bigger increases in absolute migration rates in large countries. So that's kind of China, which is the most populous country, the migration rate has increased in China, for example. So these are two, and the third one would be both of these are true, and there have been kind of nonlinear changes in population and absolute migration that explain this. So I'd like to, I'll come back to this, so think about which it is, and I'll come back to it a bit later and ask you all to raise your hand to see which one you think is correct. So do some thinking about that, especially if the rest of the talk is boring. So, because now we're going to get into Bayesian hierarchical modeling. So, Bayesian hierarchical model for net international migration rates. So at bottom, this is very simple. We model the net international migration rate denoted by R sub CT in country C and time period T by an autoregressive time series model, an AR1 model. Extremely simple. So we posit a long-term mean for a country. So R sub CT minus mu C, the long-term rate for a country, is phi C, which is the autoregressive parameter, times the same quantity for the previous time period, plus IID at random error term. So really simple. We'd like to estimate this for each country separately, but there are 3 parameters, and for each country, here 12 data points. So if you estimate 3 parameters with 12 data points, you're going to, probably some of the time, especially as we're looking at 200 countries, sometimes some of these estimates will be kind of off by sampling error and will could lead to kind of wild and crazy projections. And we'd like to, we'd like to limit the extent to which that happens. And the solution here is for each country we draw on information from other countries. And the technical approach to doing this is Bayesian hierarchical model, which I'm sure many of you are familiar with. And just a bit of kind of verbal description. The model parameters, the 3 model parameters for countries are just for the 200 world countries are distributed in some sense around a world average. The world average parameters themselves have a prior distribution, which in this instance will be pretty spread out and uninformative. And then this defines a Bayesian hierarchical model, which is estimated in a Bayesian way using Markov chain Monte Carlo, or MCMC. And in terms of the output, one thing that comes out of it is the so-called partial pooling, that the estimate for a country is a weighted average of an estimate based only on its data and the world average estimate. And the weights depend on the various the variances that go into it. And this gives a sample of many possible future trajectories of migration in all countries and periods. And this is so converted to age-specific rates using past data, if these are of reasonable quality, which they usually aren't, or model schedules, where basically there's there's a strong, it's difficult to estimate migration statistically, but one of the saving graces is that there's a very strong age pattern of migration, which is basically of international migration. People migrate almost always between the late teens and the early 30s, and of course when they migrate they bring their kids with them, so you get a kind of a pulse of a pattern where there's a certain number of under 5s, and then you get in the late teens to early 30s you get people migrating. And to a first approximation, nobody migrates internationally past 35. So how many people here were not born in the United States? Okay, yes. So that's, and how many people of those of you who were not born in the United States, how many moved to the United States after age 35? Okay, so so empirical verification. Oh, was there?
No, it's a question.
Oh, it's right. Okay, you didn't. Yeah, I've done this a number of times, and this is like 0 out of like 15. So this, but actually at Harvard, I did almost one guy had moved to the US after 35. So he was an outlier, but I've only it's kind of remarkable. Yeah.
Does this model make any attempt to sort of take advantage of some of countries being similar in many ways? For example, Benelux countries, or do they treat Belgium, its relationship to Netherlands, the same as it would treat Belgium, its relation to Sri Lanka?
So that's a really good question, and I was going to leave that to the end, but maybe I just answer. I mean, the answer is no. Although we, if you're trying to do projections for an individual country, it doesn't matter, right? So the question is, why would you be interested in this, and in spatial correlation, basically? And the reason is you'd be interested in it if you're trying to do aggregate predictions of migration for a region of neighboring countries, right? And then correlation could come in. It turns out, it's difficult, it's challenging, because there's, of course, a huge literature on spatial statistics, which you've contributed, many, others, including some here, have. And but it's all the same kind of spatial correlation, which is that basically units, observations that are close to one another spatially tend to be similar. So you've positive correlation that kind of goes down as you get as the distance gets bigger. Right? That's all. The entire spatial statistics literature is devoted to this. In migration, you don't have that. So you have both negative and positive correlation, and it's hard to kind of know just from spatial location which it's going to be. So you think of the Mexico and the United States, for example. So when Mexico has high migration, out-migration, so high negative migration, the United States is likely to have more positive migration. So you get negative correlation between migration flows between Mexico and the United States. On the other hand, and you said Benelux countries, I mean, I don't have the data off the top of my head, but for those, but another example is, Latvia, Lithuania, and Estonia, which are Baltic countries, 3 small countries on the west of what used to be the Soviet Union. And they're basically, when they're buffeted by the same economic winds, and when there's high out-migration from one of them, there tends to be high out-migration from all of them. So they have high positive correlation because they're neighbours. So we have this pattern where, there's some neighbours sometimes have negative correlation, sometimes they have positive correlation. And the spatial statistics, literature doesn't address that situation. However, so Jan Azos and myself, we actually did write a paper recently about trying to do this, and it's a kind of regularization thing. It was the best we could come up with, where basically if countries are, the correlations, if countries are not close to one another, we regularize, and if they are close to one another, we don't regularize much. And the regularization method, it ensures positive definiteness and so on. So, and that was actually, I think it is either just published or about to be published in Annals of Applied Statistics. So, but that's I actually don't. I think it's it's an advance, but I don't feel in the end it's probably the best way to go. Yeah.
So in terms of the example that you gave a moment ago about Argentina and emigration from Argentina, the story there was essentially one that could be interpreted as structural, which is to say you get mass immigration from Argentina because of the existence, if not civil war, violence mediated by the state. And it sort of begs the question, is there interest in measuring the structural predictors of what pushes immigration versus emigration, such as the likelihood of an instance of civil war or growth collapse, or modeling relative growth trajectories between countries as pushers of immigration?
So there's great interest in it, and it's a great question, which is always the first question asked in the open session about this. And it's kind of obvious that migration actually is driven by the kinds of things, to a large extent, that you're talking about. However, it's not included in our model, and and it's not typically included in models of migration that go beyond a very short time span. And the reason is that to predict, basically to do that, even when you know that there are relationships, you would have to predict these quantities. And migration actually is probably actually changes more slowly than some of the things you're using to predict. And these are very difficult to predict. So in 1950, if you'd said the future, or what is the future of Argentina, it looked great. Similarly, if you looked here, you look at the United States, is it going to become a country of emigration? Everybody'd say, of course not. But, maybe in 30 years, everybody will be flying the United States, which is what happened with Argentina, which was another land of opportunity. But it's hard to predict these in advance. And it turns out, actually, we made many efforts to sort of do this, and we just couldn't find anything that was useful predictively. And I kind of tortured John Azos trying to get him to essentially do something that would implement what you're suggesting, but really nothing did. And it turns out basically that the best predictor of the future migration in a country is really the current level and the past, particularly the recent past. So and that given that, it seems that nothing else is really terribly useful for prediction, which is kind of maybe a bit counterintuitive, because exactly what you're saying makes total sense. Okay, so the model specification, this is for those of you who have a great hunger for equations. So this is the level 1. This is the autoregressive model that I already showed. So there are 3 parameters per country. The autoregressive parameter phi c, which is just given a uniform 0-1 distribution. So there's the country mean, which has a normal distribution, and the country variance of the error term, which has an inverse gamma distribution. And there are 4 hyperparameters to be estimated here. These are each given spread out priors, which take this form, and then the whole thing is estimated by MCMC. So I'm not going to go into more detail on that. If anybody wants to ask any questions about that, now's the time, because it's light on equations.
I sort of have a question, but it's sort of half-baked. So why is the assumption that AR1, why is that the right assumption? Why isn't this, we've talked about how hard it is to predict migration. Why aren't we assuming like a random walk or an integrated process or an I1 or something like that?
So random walk, the thing is, it goes, that's a good question.
So the difference in migration might be AR1.
Yeah, but if you project, so the problem with that is you project into the future, the variance increases. Variance is a linear function. It increases linearly with lag. So essentially what you get is, if you go 50 years into the future, for example, you get just massive migration, huge variance, which is essentially implausible. So we kind of know that there are limits. And with AR1, what you get is the predictive variance, it increases, but it sort of is bounded.
Okay.
So, and that fits the data a lot better. Okay. But it's a good question. There's been in demography, there have been efforts to do that kind of stuff, but then it turns out you have to put limits on it, and you have to come up with arbitrary thresholds, and which you can't really estimate from the data. So I think in my view, it's not terribly successful. So
I have one chance to ask about MCMC. And just a quick question. You can do all this with a Gibbs sampler?
Yeah, actually, this particular model, and we implemented it in JAGS, actually. Some of the other demographic stuff is not, involves more complex models, which, you have to, or we have to, code it ourselves and so on. But this actually, after a lot of, we kept, basically what happened, we kept doing more complex models, and as the research proceeded, it seemed like the model got simpler and simpler as we found that all these fancy ideas that we had turned out to be useless. So, so we ended up with something that was simple and runs, we can do 1 million iterations like in half an hour or an hour or something like that. So, okay, the ensuring balance. So the problem is net migration can sum to 0, in fact sum to 0 across the globe for all periods and both sexes and all age groups, which is what this issue that you asked me about. So this is a fact. But trajectories from the Bayesian hierarchical model don't do so. So what do we do? Well, the solution is our solution we take each trajectory from the Bayesian hierarchical model, and we post-process it for each sex age group to ensure balance. So basically, we redistribute the surplus from each trajectory, and in each period and each sex age group, we redistribute it to the countries of the world in proportion to population. And that gives, probabilistic projections which are balanced. So a few, so Dan, how, in terms of time, how should I,
It's 3 now, so we're halfway.
yeah, okay, I'm not going to go, no, I don't have much more, so,
Yeah.
but anyway, discussion has been great. So, what does this look like for a few example countries? So Denmark, right, and so here we've got on the x-axis we've got time. This starts in 1950, and this is 2010 here. So there's that 60 years of historical data. These are kind of observations, and then. And here are the predictions, or the forecasts. So we see in grey here we've got trajectories. So, this is a trajectory that goes up and bumps around. This is a trajectory that goes down and bumps around. And here's one that, ends up fairly close to the median. This is the median here, these kind of stars. The 80% intervals are the solid lines. 95% intervals are the dashed lines. So, so Denmark is one of those countries that crossed over from being ascending country to a receiving country, and actually until 1960 it was pretty solidly ascending country. And since then it's been a receiving country. And the median projection is for continuing but declining in migration.
I'm sorry, how can it be rising all that way and then you immediately, on what basis is it predicted going down? What's making that happen?
Well, it's not predicting it going, what's predicted, and that's a good question, is a probability distribution. So we see there's one trajectory where it goes up, there's one trajectory where it goes down, and the median, and it's kind of interesting thing. So the best prediction, the median, is these stars, right, which are actually the medians of the predictive distributions. And that's kind of smooth. And this is a problem of communication, which you've kind of highlighted here. But actually, we know for sure what's going to happen is not going to be smooth. It's going to be bumping all over the place. So we're kind of saying we have a model that says the future is going to be bumpy, but our best estimate of it is smooth. And we know for sure that the future is not going to look anything like the median. And anybody who's doing Bayesian, forecasting of time series or indeed of multivariate quantities has to deal with that. And it's not a mathematical contradiction. It's perfectly understandable once you think about probability. But it's certainly a matter. It's an issue of communication. So this is not predicting. It's basically what you've got is you've got shrinkage. The general experience is that at any one point you get, on average across all countries, the migration has on average tended to regress towards the
Progressing toward the mean.
It's regression towards the mean. And you see that in the median, but the trajectory is actually, if you look at those, it tells you it's not the case. So, but there's a non-negligible probability of renewed out-migration, which, especially as you move towards towards 2050, it's not the most likely outcome, but Denmark could again become a country of immigration. But also, increased in-migration and quite higher than the current level. So if you look at the y-axis here, this is migrants per 1,000 population, per 1,000 Danish residents, if you like, per year. And this goes from, the history -2 to about +4. Nicaragua. So Nicaragua looks like this. We see actually, if you look, the lower value here reaches about -8. And this is a classic sending country with high out-migration. Okay, and so the median projection is for this to continue, but at a reduced rate. But again, continued high out-migration, which we see in this lower trajectory here, is possible. But becoming becoming a receiving country is actually possible by in the second half of the century. Although again, it's not the most likely outcome, but it's possible. India, different kind of story here. Here, if you look again, you see that these are all very small numbers. So India, obviously one of the, it's the second most populous country in the world now in about 5 years, it's on target to overtake China as the most populous country, with very low migration rates, less than 1 per 1,000 in absolute value. And the median projection continues near zero, but the distribution is, a lot more spread out than that. And an implication of that is that absolute migration rates would be projected to increase and get closer to the world average across countries of 5 per 1,000. Okay. Fourth one is Rwanda. And here, so this is, so these are much bigger values, right? They go from -40 to +40. And it's dominated by large spikes in the 1990s, so who knows what that was?
Genocide.
Is the Rwandan genocide of 1994. Basically, a large number of people migrated in a very short time, refugees out of Rwanda, and then over the following 5 years, they basically all came back home. So the median projection is close to zero, but the distribution allows for the possibility of future large spikes. And it seems experience kind of suggests that in countries where there has been, very great deal of variability in the past, there's at least a possibility of large values, positive or negative, in the future. Yeah.
Just to follow up on Tom's question, so the thing that we're seeing is we're not seeing much movement in the projected area for the cases where there's not a lot of variance, and so is the reason we're seeing that trend, whatever, on Denmark, is that because it had high fluctuation, so high variance, meaning the pooling is going to have a greater effect, and that's why we're seeing what looks like a sharp break in the trend? Does that make sense, right? So like high variance are
Yeah, in Denmark, I think the variance mightn't be that high because it's, the history is somewhat smooth, but you still get you still get a shrinkage.
Yeah, I'm just wondering if there's more shrinkage on these ones that appear to have a trend, where the ones where we're not seeing the break is the ones that are basically along the line.
Yeah, and also you're kind of shrinking towards zero in some sense. So here the history, on average, is about zero. So the mu c would be estimated to be very close to zero. So you get, the median would be close to zero. Whereas for Denmark, the median was positive in the historical period. Okay, so one great thing about a statistical approach as distinct from an expert-based subjective approach is that you can evaluate it more objectively by out-of-sample predictive performance, which, of course, we're very familiar with, cross-validation, the kind of, training and testing, which is particularly popular in machine learning. But here it takes the form of, out-of-sample prediction, where here we look at, for example, this is just one exercise, and of course we've done many, where we take the last 15 years of the estimation period from 1995 to 2010 and just train the model on the first 45 years from 1950 to 1995 and kind of generate predictive distributions for all 200 countries for the previous 15 years. So, and we'd like the predictions to be better. We'd also like the distributions to be calibrated in the sense, for example, that we'd like an 80% prediction interval to contain the truth 80% of the time on average. Okay, so so let's look for net migration rates. So the persistent migration, which is used by the UN and is also really used by most countries and states and everything, basically the future like the present. So the mean absolute error is 7.6, and the 80% prediction interval coverage, well, they don't have any intervals, so there's no coverage. Right? So the Bayesian migration approach from the mean absolute error is about a third smaller, which means the variance is less than half. And the 80% prediction interval has coverage 83%, which is pretty nice. And this is, by the way, 200 countries, 3 5-year time periods. So this is based on 600 cases, if you like. So how does it translate to population projections? So here we've got the mean absolute relative error, and it's averaged across countries. And so, again, the persistent migration gives 11%, and the coverage here is 40% because these predictions, they take account of uncertainty about fertility and mortality, but not migration. And the coverage is way below nominal. Actually, if you condition on future migration, it turns out, you pretend you actually know the future migration, it turns out the coverage is spot on. So that means that the method, it's doing very well for predicting, probabilistically fertility and mortality. So this is off because migration is being neglected. So the Bayesian migration, the mean absolute relative error is almost halved, which would be, the variance in that sense reduced by almost 3/4, and the 80% interval is coverage 77%. So, this was all very encouraging. The frequency of crossovers between being ascending and receiving country. So, as I've mentioned at the beginning, over the past 60 years, 46% of countries have crossed over from being ascending to a receiving country, or vice versa. And if you project forward, you'd kind of like the projection for the future from a good method to be not too different from that, right? So for, say, in this case, if we started at 2010 to 2070. It doesn't have to be exactly the same because, of course, the period is changing. But, so proportions predicted over the next 60 years. So for the persistence method, what proportion is predicted? 0, right? Because they're constant, right? So they can't cross over. For the Bayesian model, it's 49%, which is, compared with the observed for the past 46%, is, it seems pretty, pretty in line with experience. The migration paradox. So recall the paradox, which I asked you to think about. So I'm sure you've been puzzling over that for the last 20 minutes. It's basically the proportion of people migrating in the world has been increasing over the 60-year period, but the average absolute migration rate across countries, not weighted by population, has been constant, or effectively constant. So, and the explanations I said, one is that could be said, like it's U.S. population increasing. So all countries' absolute migration rates are roughly constant, but the populations of countries with higher migration rates have grown more than the populations of countries with lower migration rates. A second possible explanation is that there have been bigger increases in the absolute migration rates in the most populous countries. So that's kind of, Chinese have been migrating more, say, as a sort of a summary of that. And the third is some combination of these and maybe some other nonlinear changes. So which is it? So how many of you think it's the first one? So basically, high migration countries' population has grown more. So who thinks that? Okay, good. So who thinks it's number 2, which is the kind of China, China's migration increasing? So how many of you think that? Okay, and who thinks it's number 3? Okay, great. So that's kind of like all of the above sort of thing. Okay, so if we look at it, this is again a summary of the paradox, but the explanation is that migration rates have been increasing more for big countries than for small ones from a very low base in the 1950s. So it's explanation 2. So those of you who, so actually collectively you did well because that was the biggest vote, but I really appreciated those of you who had the courage to vote your convictions, right? So others was on the others as well. So here's a plot, and on the x-axis we've got countries. Here we have the 25 largest countries by population, and we've got absolute migration rates here. These are in migrants per 1,000 population, and the world average is around across countries is around 5 per 1,000. And in blue, we see 1950. In orange, we see 2010, roughly. So look at China here. In 1950, almost zero migration to or from China. But in 2010, a lot more migration, but still very small. India, second most populous country, exactly the same story. The United States, actually, funnily enough, the United States has below average migration rates, which and in the same story again, but the 1950 low migration rates, and in 2010 much higher migration rates, and all of these 25 countries both had and have migration rates lower than the world average, except with one exception, Italy, which has now has migration rate that's above the world average. So, and these are, big countries have much lower migration rates. And the Bayesian model actually successfully reproduces it. So if we look here, again, the proportion of the world's population migrating, we see here's the historical increase, and the Bayesian model says basically continue to increase. And for mean absolute migration rate, historically a constant trend, and the Bayesian model says that the trend in the future will also be constant. So it actually encapsulates this paradox in the model. Okay, one other thing is the proportion of predictive variance of population due to international migration. So there, as I said, there are three components of population change: fertility, mortality, and migration. Which is the most important? What are the relative contributions to the variance? And you can do an analysis of variance kind of thing. So if you look at the world, it's 2%. Okay. Now, if you think of it, migration doesn't, from one country to another, doesn't change the world population at all. So you might think that should be 0, right? So why is it not 0? Anybody?
Because people are moving to countries where they live longer.
That's a possibility, yes. So people could be moving from countries with lower life expectancies to ones with higher life expectancies, and that would have an impact on the population. Any other explanation? Yeah.
I'm following up on that. They may be moving to places where the fertility rate's going to increase.
Exactly, yes. And actually what has happened a lot historically is people move from, they move in both directions, but from higher fertility countries to lower fertility countries. And typically when people do that kind of movement, the fertility rate of women who move from high fertility countries tends to converge quite quickly to the fertility rate of the receiving country, and certainly the next generation has fertility rate of the receiving country, and that's it's well documented in the United States, for example. In Africa, 11%. So Africa is not, migration has not been a huge part of the story. Partly that's because there's so much uncertainty about future fertility in Africa that it dwarfs migration. But if you look at Germany, you find that actually 3/4 of the variance about population is due to migration rather than fertility and mortality. And actually, if you look across, that's just one example of developed countries, but for the United States, it's not too dissimilar. Majority of uncertainty about future population is due to migration, and for most developed countries, that's the case. And actually, for some small developed countries like Ireland, from which I am myself a migrant, it's like 90% of the uncertainty is due to migration. Yeah.
Just a quick question on Germany. To what extent does reunification of Germany impact the projections for Germany? Because now you have a larger population as a whole.
Possibly, because basically, I had a slide that kind of showed that, and I think I took it out in the interest of time, but basically, if you look historically, there was the biggest, there were about, in 1990 to 95, there were about 3 million net migration into Germany over that 5-year period, a lot of which was due to both, not to reunification because it was still the same country, but to people moving in, and it was part of that, the fall of the Soviet Union, the wall and so on. So that contributes to a higher variance. So that's part of it, but the variance in Germany it's not that much bigger than other countries, and this proportion is not, it's not out of line with other countries. So yeah.
I'm sorry if I misunderstand. Maybe I don't know what predictive variance is, but
Yeah.
isn't there only one number for Germany in 2100? How does it have variance? I don't understand.
So basically what you do is we're just looking at the prediction, right? So and the prediction is a probability distribution. So so basically what we did is we said, okay, I think we said first fertility, then mortality, then migration. Because whenever you do, applied regression course or something, you partition variance, and if they're not orthogonal, you have to put them in order to get a number out. So I think what we did is we saw if we kept fertility constant and didn't take account of uncertainty, what was the variance, and then we did when we took account of that. So
okay, thank you.
Yeah, that's so it's and then when we put in migration uncertainty, the variance went up a lot. So let's just go back to our friend Boris Johnson and say how likely actually is the UK population to reach 80 million. He didn't actually say what by when, but it turns out one can sort of reverse engineer what he had in mind. If we look at 2030, the answer is less than 1 in 1,000, so basically very unlikely. But It seems he had in mind 2040, and I'll tell you why in a second, but the probability is less than 2%. But so where did Boris Johnson, get this 80 million figure from? So did he kind of make it up just out of his head and just kind of, but actually he didn't. So, we're familiar with maybe some, that's not unknown for politicians to do, but in the case of Boris Johnson, no, it's not what he was doing. He looked at the UK Office of National Statistics, which is their equivalent of the US Census Bureau. They issue scenarios to sort of basically communicate uncertainty. They issue 10 different scenarios. And the highest of these, and they kind of say here are 10 scenarios, here are 10 possibilities, right? And the highest of these was 79 million in 2039. So roughly, the 80 million in the future. So Boris Johnson, he went into the ONS website and found, there's a scenario which they say is plausible, as good as anything else. It says 80 million. So actually, you can't say, given the state of population forecasting, you can't say he was wrong. I mean, you can say that the state of population forecasting is bad, but you can't say, Boris, you couldn't, he could say, well, look at the website. And this corresponds to persistent high fertility, high life expectancy, and high migration from now until 2040. And that these would all be the case is, well, as this shows the 2%, it's unlikely. So, but when you have 10 scenarios, it doesn't tell you that this is unlikely. It just tells you this is possible. So I think I'm going to just, I'll leave this for the discussion. So just to kind of summarize the most official population projections done by individual countries with statistical offices, like the United States Census Bureau, are still deterministic, but assessing uncertainty is important. And there's been a big change with the UN issuing official probabilistic population projections for all countries in 2015, where this whole area has got put much more on a statistical basis. But they don't yet account for migration uncertainty, and we've been trying to do that by developing a Bayesian hierarchical model for net international migration, which yields probabilistic population projections with migration uncertainty, and this performed well in our out-of-sample validation experiments. And one side result is that migration is an important source of uncertainty for many countries, particularly developed countries actually, which have had a history of migration. Improvements are possible. The biggest single improvement would be better data on migration, rather than statistical, but there are also statistical improvements possible. So here's some references, and there's software to do there are packages to do the population projection with fertility and mortality, and there will be a package for the migration as well. And so yeah, this is available at the group website. So thank you. Yeah, so we've got some time for questions. Yeah. So there's a tradition which is in a number of places. I just learned about on this trip actually, which is, and I think it's a great one, that the first questions should be asked by graduate students, and faculty have to kind of suppress their burning urge to give their perspectives until graduate students have had their say. So please, if you're a graduate student, you have a question, please ask it right now. Or an undergraduate student.
We're going to judge you if you don't ask a question.
Yeah. No. And there are no dumb questions. So. It's okay. We can wait for a minute while you. Yeah.
Do you have any estimate of return migrants?
Ah.
Meaning people who migrate to a country but then return within the time frame that may have an effect on your estimate?
So the United Nations definition of migration is a migrant is somebody who moves to another country and stays there for at least a year. Right? So basically, if they return within the year, then it's not migration. So if you do a semester abroad or something, that's not international migration. But there is a lot of return migration in that a lot of people who migrate do return to their home country or maybe move to another country eventually. And it's been so this is a great question. It's been very difficult. It's very difficult to estimate that. Basically, you're talking about estimating past numbers because of the, just the difficulties of estimating anything other than net migration. But as it happens, so John Azos and I, we've been working on that problem, and we have a paper that has been accepted by PNAS, by Proceedings of the National Academy of Science, and is in the last stages of kind of editorial production. And one of the things about, so this is these so-called high impact journals like Science and Nature and PNAS, they're very strict about not letting you diffuse or disseminate or talk about your work before it gets actually published. So I'm hoping this will be published this month or next month. And so if I was giving this talk a bit later, it would be, I'd probably focus on this question. I think we've come up with a new method that for the first time provides high quality estimates of between country migration for all pairs of countries. And it's based on, there's an interesting thing, which is that flows, so these are called flows, movements between countries in a time period are called flows. There's a lot of good measurement on what are called stocks, which is the number of foreign-born people living in the country. And the reason is that almost all censuses ask people, where were you born? People know where they were born, and usually they're prepared to answer that question. So you get good estimates of the number of people from each country in most countries. And it's been very hard to use that directly because, if you have somebody who's 50 years old and moved, they were born in Nicaragua, then, they could have moved last year, or they could have moved when they were 2 years old. And really, it's just very hard. Or they could have moved to, they could have moved to Mexico and then to Nicaragua, and you miss all these things to the extent that really, in terms of estimating flows, it's just very hard to do much with these numbers. But we've kind of figured out, I think, a way of using these numbers and using them over time to actually get good estimates of at least, unbiased and reasonably good quality estimates of flows between countries. And particularly what comes out of that is return migration. So another thing that comes out of it is transit migration. So essentially, if somebody moves, they're born in El Salvador, they move to Mexico, live there for 10 years, and then they move to the United States. That's transit migration. And so it's a really good question. And one thing more generally, I think, this area is a very we're the only statisticians that I know of actually working on this estimation problem, along with a guy called Guy Abel, who's now at he's a professor at the University of Shanghai University, who has done some super work in this area. But it's very challenging statistically. And more generally, statistical demography, there are very few statisticians working on it. I'd say one could really, one could count them on the fingers of two hands. And but the area is highly statistical. It's the statistical analysis of human populations, and it's very important for all kinds of things, including health, public policy, and the private sector. So there's a lot of opportunities, I think, for statisticians, which are ripe for the taking. There's a lot of low-hanging fruit in terms of research and so on. So that's a good question. Any other? Yeah.
How do you balancing the trajectory between the age groups, or would it even be more advantageous to just start your trajectory from different age groups and balancing them together?
Yeah, that's a great question. So basically, what we did was, it was in a sense very simple. So we took each trajectory, and then we took so we just considered, say, 50 to 55-year-old women, right? And then we looked at the migration in that trajectory in that time period. So say women, well, 50 to 55 in the period 2005 to 2010, right? Or, sorry, we're looking into the future. So in the period 2020 to 2025, right? So what, and so each trajectory has a number of the net migration of 50 to 55-year-old women in 20 to 25, and that number is net migration. And these numbers for all countries have to add up to zero. But in the first pass, what comes out of the Bayesian hierarchical model is not zero. It sums up to something. So you might find there were, 10,000 extra women, if you like, came out of that. And the only other, the only explanation that it's impossible because they would have had to come from outside the country. So what we did is we just took that and we redistributed these 10,000 women to the world's countries in proportion to population. And we did that for each age group and each sex age group. So it's just a very simple kind of redistribution. And one could definitely, I'm sure one can think of improvements to it. But typically these surpluses are actually quite small typically, so it's not if you don't correct it, you can get quite counterintuitive things happening. But at any one age group and time period, the numbers are quite small, so it doesn't, I think changes to the method wouldn't make a big difference. But it's definitely one thing that could be considered and improved. Any other graduate students? Yeah. Okay, well.
First faculty one.
Okay, so.
Do we have more graduate student questions?
No? Oh, yeah.
This is just purely a curiosity question. When you present these kinds of results, rather than these deterministic models, how do policymakers and people respond to not having a pinpointed number into the future versus an 80% or a 95% interval around the median?
Well, of course, it hasn't been adopted officially, right? So we've been presenting these to the UN Population Division, and who haven't yet adopted them, although they're discussing it. And there's various, so they're in the intermediate thing, they're not policymakers. They're kind of considering, they're technical people themselves who are considering how to, what numbers to present actually to the broad public, but mostly for use by policymakers. So there's, migration is so sensitive, there's, there's a great deal of sensitivity about it. And there's kind of interesting things that happen. So I was talking to the director of the UN Population Division, who's John Wilmot, who's actually a famous demographer who was a professor at Berkeley before he took this job. And he was saying, there's difficulties like, for example, Canada has a quota system. So they say we will take no more than 250,000 migrants a year. But our model, of course, gives a possibility of higher numbers than that. So it's kind of awkward to tell the Canadian ambassador whether your quota for migration is going to be, it's going to be exceeded. Which of course is not a statistical issue. And I kind of thought about that and looked, and I went back and, if you look over time, the Canadian quota for migration, they're one of only 2 countries with quotas, but has been increasing over time. So every year it changes. And so in a certain sense, to incorporate it, you'd have to predict what the quota will be. And actually, as it happens, we now have a collaboration with Statistics Canada. The guy who actually is in charge of the Canadian population projections, called Patrice Dion. And we told him the story about the interaction with the UN, and particularly the Canada, and he said, Statistics Canada, we pay no attention to these quotas, they change so much that they really are irrelevant. So you kind of, so over time I think there are some of these issues. I think that there's a lot more receptivity to it. I think in terms of, there's a more general issue, which is how do policymakers react to uncertainty and being presented with uncertainty ranges. And there's so I'll give kind of 2 answers. One is there's a kind of experts tend to feel, the ordinary people don't understand probabilities, right? So you have to give them a number. And there's also a feeling policymakers don't understand probabilities and ranges, and you have to give them a single number, and they want, tell me the number, which is to some extent true for policymakers. But the question is, what's the number? So the first thing is you should give them the best guess, right? But actually, that may or may not be the case. So if you think one important application of demographic projections is decisions about school construction and school closings. And so in the United States, there's a big industry of demographic consultants. The school district, and this happened to us in Seattle, school district was, there were fears about, there was actually white flight going on, and there were fears about its future implications. They got a demographer who said, well, the trend has been downwards, the number of kids is going to go down. They closed 4 schools, and there were ructions. It's very tough for communities who've built their lives around a school, and so there were demonstrations, but the schools were closed, and then it turned out actually the number of kids that didn't go down went up. So then they were trying to, they were cramming kids into trailers and everything. The school board members were all voted out, and there was general unhappiness. And actually there was an interview with, I think, a guy who was president of the school board at that time, and he said, if we'd only known the demographers could be wrong, we'd have made a different decision. and so I think that's, the United States, there are school closures all over the country happening that should not happen. Because you should not close a school, even if the median basically says there's going to be fewer people, you should not close a school unless you're fairly sure that you won't need to reopen it again. So, and this is just, so it's kind of one of the evils of deterministic projections is you actually make the wrong decision. So a number is needed, but the number should not be the best guess.
Mm-hmm.
Because with the best guess, you have a 50% chance that you won't have enough places. What you need, and given most states, maybe in the whole country, it's mandated that the state provide enough places for educate, at least provide elementary education. We have that in the state constitution in Washington. So that means you need, what the number you need is a kind of an upper bound. You want to be fairly sure. Precisely what it should be is, but I think, say a 90% quantile is the number. So maybe, and the only way you can really get at that is by probabilistic projection. So I think this is a kind of example, but maybe the policymaker, maybe the governor or whatever, maybe only needs the upper bound, doesn't need, but the median, doesn't need the distribution, doesn't need all this stuff, but can be told, well, to fulfill our constitutional mandate, we have to fund this number of places in the state. But then, you've got the state legislature, legislators specialized in education, they understand more of this. I have a former PhD student who's a state representative in Washington State, and he's chairing some of the committees that actually do this kind of stuff. So you've got somebody who's a PhD in statistics actually doing this, and then the state House and Senate staffers, they understand it, and the state, obviously the officials who are implementing it, they're much more receptive, obviously, to multiple numbers that they have to handle. So there are also different levels, but I do think that giving a single number as the median, which is what's done effectively by default around the country, is it has bad. It has bad consequences, and I've talked to the school construction, school closures is maybe the most kind of egregious examples of this, and I've talked to people making experienced people making decisions about school closures, not just public school but also parochial schools and so on, and they all agree. They say, yeah, that it's I've seen this play out a number of times. So yeah, so I guess we can allow the faculty to ask their burning questions.
Ciao.
Oh, yeah.
So my first question is actually the same as the previous one. So my
Okay.
second,
But is there any? I mean, is there anybody who has a question that hasn't been asked? Is it the same question?
I have another question.
Oh, good.
Yeah,
So
yeah,
that's the other question. Yeah.
My first question is also about the same sense and how can you communicate with the public. So then my second question is, when you do this models, it seems that in most models, median will basically regress toward zero in the long run. So what would happen for the variance? If you calculate the variance, the variance of the projection population, would that actually increase over time?
So,
because it seems that intuitively, because this as the cumulative of the error, the variance would increase.
So, so what happens? Okay. So we get a shrinkage. Well, there's a kind of a double shrinkage going on. So here, Denmark. So there's a long-term mean, which is a shrunken version of the empirical average. So the mu's, which are the country-specific means, they come from a distribution, and which in turn, a priori has a zero mean. So the long-term means, to the extent there's uncertainty about them, which there is on a limited time frame, their estimates get shrunk towards zero, but they're not zero. And then the medians also get, or means, posterior means get shrunk towards zero as well. So in Denmark, you've got two things. One is this is the long-term mean here, is that, say the value of the median in 2100. So you get shrinkage of the predictive mean to that value. But then you also get the long-term mean in Denmark, I think, is probably slightly higher than that, and it gets shrunk slightly to zero. So that's what happens to the mean. So a bit of shrinkage, but it's informed by the country history. And then in terms of the variance, so the variance increases, and it's an AR1. So basically what happens with an AR1 is the variance, it increases over time, but it effectively asymptotes. So it gets closer and closer to an asymptote, which is given by the innovations variance and the autoregressive parameter. There's an additional component of variation here, which is that we don't know exactly what the autoregressive parameters are. So that uncertainty gets also factored in and leads to further increase in variance. So we see basically the variance increases, but the intervals, they sort of plateau out as you go further into the future. So you avoid this. The person who's sitting there who kind of said, why not use a random walk? And in a random, if this was a random walk, what you'd see would be you'd get huge intervals in 2100, which would be allowing for like millions of people flying in and out of Denmark, and it would be completely implausible. So, but you don't get that very extreme thing, but you do get some increase in variance as you go forward in time. So maybe yourself, since you have those.
Are there enough countries that look like Rwanda to justify modeling those differently?
Well, yeah. That's a really good. It's a really good question, and one part of it it's a refugee movement, right? And it's kind of an ironic thing that the one kind of it's very hard to know what migration flows are. However, refugees are actually counted quite reliably. And the reason is that the United Nations High Commission for Refugees actually kind of registers and counts refugees, even though they're the most vulnerable people. And more vulnerable people are usually counted with less precision than less vulnerable people. For migration, it's the opposite. Is the refugees are actually counted fairly reliably, whereas the opportunity-driven migrants are it's much harder to count. So we could separate them out actually, and it might be a bad idea to predict future movements of refugees. You'd have to mostly they're driven by conflicts like the Syrian Civil War, or here the Rwandan genocide. You'd have to be able to predict when and where these conflicts would happen in the future, and that's a mug's game. Really. You're not going to be able to do that. But on the other hand, there is return migration. So refugees, they often return home. It's not easy to do that, and there's a lot of uncertainty about that. But if an event has happened recently, then you might be able to improve your estimates of migration by predicting return migration. On the other hand, it's an empirical question whether that can be done with enough precision to be useful. So if you think here in Rwanda, basically there was huge migration in 1994, people fled the genocide, and then, after 8 months it ended and the Civil War ended and everybody came home. So there was a very rapid return. At the other extreme, 1948, the Palestinians were mostly expelled from the Israel and Palestine, and it's 60 years later or 70 years later, and most of them have not returned. So patterns can be quite different. So it's not it's not a fail-safe, but it's definitely something that's worth considering. And there are just a few. I mean, you're right that there aren't many countries like this in the data set. I think there are two other examples. I think Cambodia, where there was a sort of return migration because there was stabilization after the Khmer Rouge were thrown out in 1979, right? And then the other one is Yugoslavia, where there was 10 years of war. So you had and these are now like 6 countries. So there were quite a lot of big migratory flows of this kind, and the fact that there had been, if you're just looking at the data, the fact that there had been flows in the previous periods was a signal that there was quite a chance of variability. So there's a kind of statistical thing here, which is an oddity, which I still don't understand, which is there are outliers in the data, right? And we're using a normal distribution. So it seems like normal distributions don't have long tails and don't accommodate outliers. So it seems we should do something else, right? And we thought, okay, let's use a distribution with long tails, so t-distribution, right? And so we did that. We did the whole thing with t-distribution. And we found that in terms of quality of intervals, it was much worse than normal distribution. So the normal distribution actually inflated the variance, and that gave intervals that captured the truth well, even though the likelihood for the t-based model was a lot better. The intervals were a lot better for the normal-based model. And that to me, it's a kind of an interesting thing. It casts some doubt on automatic use of likelihood for everything, but I don't fully understand. I still don't fully understand that kind of contradiction. Yeah. Sorry. Maybe we can go because you didn't.
Thank you. Thank you. So far, the results are demonstrated mainly from the prospective applications. So I was wondering, say, if you look things, retrospectively, in the sense of whether you can use this method to, say, distinguish or in some sense, demonstrate the effect of certain immigration policy. For example, if you're just using, say, the end of Obama's government period, just making prediction for the future, say, 30 years, and then we have Trump's government data, you can just make another prediction, and can you just see this very significant difference between the pattern you're predicting for the future?
So, we haven't done that, and it might be worth trying it, but I think it would be very difficult, and my gut feeling is that you wouldn't get much out of it. And an example is, the two countries with the kind of strongest immigration policies in the world are the ones with actual immigration quotas, overall quotas, and that's Canada and Australia. The United States doesn't have a quota, right? It has, for particular, like H-1Bs and so on, there's limited numbers, but most migration to the US, international migration, is by family reunification, and there's no cap on that. So there's no real the differences between the Obama and Trump administration, probably they're more in rhetoric than in reality. But for Canada, there are quotas, right? And as I told the story about the Canadian quotas, that actually you try and use them to predict, it's kind of useless because the quotas change all the time in response to circumstances and to political winds. And I think in the United States, probably the same is true. My guess is you just wouldn't get a lot out of it. And of course, there's also to some extent, if you have a restrictive immigration policy, it gets frustrated to some extent by illegal migration, but also it changes, right? So you would need to predict the 2020 presidential election, right? So how good would you be at doing that? And you'd need to predict the 2024 presidential election and the 2028 presidential election, and you'd need to predict what the policies would be of the people who are elected, and also whether they get through Congress and so on. So it seems difficult to do, but that doesn't mean it shouldn't be done. There's a real distinction between looking at the past and explaining the past and predicting the future. So there could be things that are kind of actually are linked to migration. There's no doubt economics and policy have an important impact on migration. But to use them effectively and usefully for forecasting the future, you need to forecast these things in a reliable way. And you also need to forecast the future relationship between these things and migration, which can also change with circumstances. So there is actually, and that's much more difficult. And it may turn out that actually you would the predictions would get worse if you try and add in things that are poorly forecasted. You can actually degrade the forecast rather than improving, even when the relationship you're using is a reality. So it's a tricky thing. Oh, sorry.
Yeah, so I wanted to ask you something, about forecasting the future and using the past data that's used. So if you look from 1950 to 2000,
Yes.
there's one huge change in the data which is relevant for future forecasts, which is just the number and boundaries of nation states themselves, right? So from 1950 to 2000, there's a huge increase in the number of the world's nation states because many large nation states like the Soviet Union or Yugoslavia and others are disintegrating. And if I have one certainty in terms of projections for 2100, with probability 1, the number and identity of nation states in 2100 is not going to be exactly the same as it is now.
And actually, it is with probability 1 because it has already happened.
So my first question is just sort of a technical one. How do you deal with that going back into the past? So are you assuming parameter stability for Ukraine vis-a-vis the Soviet Union, right? So when Ukraine is created, is T minus 1 the Soviet Union, same thing for, say, Serbia and Yugoslavia, so on and so forth. And thinking about the future, of course, there's nothing that one can do obviously systematically, but in terms of presenting things to policymakers, there's a sort of fundamental level of uncertainty here, which isn't about wasn't about the parameters that you identify. It's just about the boundaries of the units that you're concerned with, and that might be relevant if the disintegration of nation states, like in the case of Yugoslavia, is associated with push factors associated with
So that's a really great question, and so essentially, it's one of the advantages of working with the United Nations that there's at least a partial solution to that. So essentially what the UN updates, every 2 years they update, the past history, demographic history, by country, and when the boundaries of countries change, what they do is they re-estimate the past on the basis of the current nation states. So for Ukraine, for example, they don't actually do estimates Ukraine to Russia. It's net migration from Ukraine, and typically, even though the nation states change, typically when they change, the new countries correspond to, high-level administrative regions of a former country. So the Soviet Union, for example, broke into 15, but these 15 actually were Soviet republics, and they had their own official statistics, and so on. So the UN basically has all these things, and when that happened, they just basically were able to go back and recreate the world population prospects for it. So Ukraine, estimates of migration going back to 1950 for the Ukraine. So that's, but there's a really, there's another thing which you get at, and which is a limitation of this. We just assume, as you said, pretty much all demographics assumes that national boundaries will stay the same, whereas we know, in fact, they're not going to. And to some extent, that's because the number one users of these things are they're government officials, right? So if you're in the health ministry of Venezuela, well, maybe it's a bad example, but
maybe it won't be here.
Maybe you won't be here, but of Mexico or something, you're going to be making plans for Mexico, and the idea Mexico might split up in 30 years. It's you kind of condition on that not happening in some sense, but still, migration. It is true that when, Russia, the Soviet Union gives the example, there was quite a lot of migration within the Soviet Union between different Soviet republics, and when they became separate countries, it's quite possible that kind of changed the situation. So and made migration perhaps less common, or could do. So you know, you could be using a pass that's that had some different circumstances in terms of what national boundaries are. And you know, I kind of know my wife is she's from the Czech Republic, and she grew up in a country called Czechoslovakia that doesn't exist anymore. And in 1992, it split into two, into the Czech Republic and Slovakia. And they each speak their separate languages, Czech and Slovak, which are similar languages. And they're similar, and people can, you know, they could understand one another, but they're not the same language. They're like maybe Spanish and Italian or something. And so, you know, when she grew up, the TV was, you know, was on sort of Czech and Slovak, and the parliament, they'd speak whatever the language was. It's split up in 1992, and she just knows the two languages. But her nephews and nieces, who grew up in the Czech Republic, they don't understand Slovak because it is a different language. So you know, when you're the same country, being in the same country, it's different from not being in the same country, even though they're both now in the European Union and so on. So I think you're getting at something that is that is potentially important. It's very hard to see how to deal with it, but it's a, you know, it's a caveat, and it's a caveat probably that government officials don't want to hear, because it's sort of, well, your country mightn't exist in the future, so they prefer not to even consider the
If you're having
possibility,
this
even though
conversation with Spanish officials, it might be
particularly sensitive. Exactly, yeah. So, yeah, any other, Ted?
Yeah, so when I was talking about grouping similar countries, I wasn't necessarily thinking of spatially. So for example, maybe you should borrow information by grouping Canada and Australia, which are both resource-based countries with an English heritage and
Absolutely.
something like that.
And they're the two countries with immigration
Or maybe Iceland with Finland, which are not very close, but very similar in many ways.
Yeah, and you know, that's a really good point, and it might be useful for migration. I don't know. We in some sense tried to do that with our, you know, this work on trying to estimate correlations between net migration flows, which sort of was a way. Actually, I think something like that came out of it implicitly. It turned out actually that something like that, looking at fertility, we did build in between country correlations, and we were, like you're suggesting, we were agnostic about what they would be, and we looked at, you know, fertility, actually residuals from the prediction model, kind of for all countries, and we looked at correlations. Pretty hard to estimate correlations, the correlation from 12 data points, because if it's actually zero, the confidence interval, or actually estimates, and you simulate estimates, a kind of confidence interval would go from -0.6 to +0.6. So if you take the 40,000 correlations, and suppose there's no correlation at all, they're all zero, you find correlations that are spread all the way between -0.6 to +0.6. So you need to do some regularization and use some characteristics, and also that can be very useful and relevant for the reasons you suggest. So we looked at various measures of not just distance, but also similarity. And we found that correlations were well predicted between fertility flows, were well predicted by three characteristics of the pairs. So it's 40,000, you know, directional pairs. Well, 200 countries, so 20,000 pairs actually. 200 choose two. And of these 20,000 pairs, we found that whether or not they shared a border, whether or not they were neighbors, that was important. The second thing that was important is whether or not they were in the same UN region. And the UN divides the world's countries into 22 regions. And they're two criteria essentially. One is, you know, are they geographically contiguous? But the other is, do they share some kind of historical and, you know, cultural similarity? So North Africa, for example, is a region, and they are typically Muslim countries with, you know, Arab populations and so on. You know, Western Europe is another. And the third one is an interesting one, which goes to exactly what you're saying, which is, did they have the same colonizer in 1945? So if you think of, say, you know, Cambodia and Algeria, correlation between those on one hand, and the correlation between Cambodia and Egypt on the other, which would be higher?
The first.
The first, so Cambodia and Algeria, because they both had the same colonizer in 1945, which was? France, right? And whereas Cambodia and Egypt did not have the same colonizer. So that's, I mean, it's not a huge, it makes a difference of about 0.05 to the correlation, whether they have the same colonizer. And these are countries, you know, really far away, but one can actually trace mechanisms. You know, there's actually the, you know, government officials from these French-speaking, you know, or countries with French colonial heritage, they get together and they talk to one another, they share ideas. Similarly with countries with English, you know, that were colonized by the UK. So actually, I mean, you're absolutely right, there is evidence. Not, you know, we didn't really uncover it for migration, but per se, but I think one could. Because there's clearly, you know, these colonial relationships are important. Whether they'd be very important going forward, conditional on the past, is not clear, but they could well be. So I think that's definitely a possible improvement. Yeah, okay. I guess this is maybe the last question. Right?
Yeah, I think that's good. Last question.
So in terms of the statistical methodology, is Bayesian method a minority in the field of demographic? Because it seems that is a first order autoregressive model, and if you do not estimate the parameters directly, then you use the hierarchical modeling to give some prior, and the prior are very intuitive from the model specification, the Gaussian inverse gamma sines. So I mean, that what is the intuition from to use the hierarchical model here? Because I remember you mentioned that the data is too few for a single country, so you want to use the prior to borrow information from other countries. And if there is any reason that the hierarchical modeling is better than estimating directly, so what stops the previous literature to try this?
So I'd go even further. It's not just Bayesian approaches have been a minority, but actually statistical approaches. So statistics has been kind of, you know, modern statistical thinking and modeling has been effectively largely absent from this particular field, which has been dominated by deterministic mathematical models that don't include, that don't model uncertainty and variability in the way we're used to in statistics, and that probably everybody in this room is familiar with. So, so that's, you know, this is a kind of it's a pretty profound change in culture actually, because and the discussion about, you know, like we know nothing about it, we assume it to be zero, whereas, you know, it's exactly, you know, 180 degrees wrong, right? But when you have a mathematical sort of perspective, you think that way, and it's a sophisticated field mathematically. So it's, you know, it's definitely in technical terms, it's one of the more sophisticated areas of the social sciences. In terms of why the hierarchical model, so, you know, it went from no statistics to Bayesian hierarchical modeling, right? So it kind of jumped over the frequentist, the kind of intermediate frequentist era, if you like, and the reason for being, well, especially for being hierarchical is you've got a lot of countries, the data are limited on each one, but patterns, there's a lot of commonality between patterns, right? So what happens in other countries can tell you quite a lot about what's implausible, right? So, and effectively the Bayesian hierarchical models provide a kind of unified way of building that in. And so what happened is when we started doing this, and then initially the UN people and then subsequently other demographers started seeing the results, they said, oh yeah, this it works. You know, it really corresponded to. So previously they were spending ages, you know, looking and trying to adjust things and sort of, oh, this is odd, and, you know, and pushing and shoving projections so that, and then suddenly you're Bayesian, you just run the method, and what comes out, you know, to a first approximation, sort of works. I mean, it doesn't. There's still careful review of the results, sometimes adjustment of strange things, but by and large, in the majority of cases, it works pretty well. So both of these, the intuitive kind of thing that, which demographers, I mean, they're very smart. So intuitively, when things are out of line, they know it, and they do some kind of adjustment, some kind of manual adjustment. The Bayesian approach tends to do that fairly automatically. So, yeah.
Okay, well, we'll end there. Thank you very much. I told you he gives the best talks.